Hi, my name is Mark Lazars. I own a ShopSaver 23 CNC router. ShopSaver bundles WINCNC control software with their machines, and it's packed with a lot of neat features. I thought I'd take a little time to go over a couple of often overlooked positioning features that are built into this software. Okay, so after my computer has booted, neither the software nor the machine are running. So first of all, what I'm going to do is bring up WinCNC, and here you see the usual ShopSaver user interface. Now, when we look at these numbers, where do they come from? Well, let's turn on the machine and see if we can figure that out. So after turning the switch on, the machine is in the park position that I left it, and I have it propped up with this block so that the collet doesn't hit the table. So let's take a look at the screen again. You'll notice that the X, Y, Z, and in my case I have the fourth axis A, they're all showing in red. Well, one of the things that the manual recommends is before you home the machine, you test to see whether or not the limit switches actually work. So if I go over here and push the X limit switch and look at what happens on the screen when I press it, you'll see when I press the X limit, it shows an arrow saying, yep, that switch works. And now I'm going to press the Y limit switch. Yep, that works. Now I'm going to press the Z limit switch, and yep, that works. Well, there's no limit switch on the A, so that means all the limit switches are working, so we can go ahead and home the machine. So what I'm going to do is just go over here to the home button and hit that. So the machine is now homing, and you'll notice that once the limit switches are touched off, the X, Y, and Z values on the DRO turn from red to white. What that indicates is that those axes have been homed. After the limit switches have been hit, the spindle actually retracts a little bit, and that position is just off the limit switches a little bit. You can see here, and the same with the Y. So it's off a little bit, and the spindle is actually over the edge of the table. It's not even, you can see it's kind of off the edge and off the edge in this direction. So the home position is really kind of useless in terms of being able to use it for running a job because it's off the table. So what do we do next? Well, let's take a look at the screen and see what the DROs say. Alright, we can see that the X is at -12, the Y is at -10, and the Z is some number. For most of this discussion, we're going to ignore Z, but what's interesting is that those numbers represent the head position relative to the last time that I used this button to zero the X, Y values. That's something to think about. So even though the machine was off, it still remembered those X, Y, in fact the Z values that were set prior to this, even in a different session. So where was that? Well, I'm using a little painting cone here, and I wrote down That's the job XY0 value as like a pretend position for where that was set previous to this. So if I go over and manually type in G0, X0, Y0 and hit enter, you'll notice that the head moves over to exactly where the job was set up before. So now if I type in G0, Z0 and hit enter, it went right down to the Z value that I had set before. So that just proves that even though the machine was off, it remembers those values. Alright, now let's take a look at the DROs. Alright, there it is. X0, Y0, Z0. But look where it is on the table. It doesn't have, it's nowhere near where that machine homed, which would have been over in this area over here. So what's the difference between this 0 and the home? And the home didn't even indicate that it was 0. Well, the difference is what they call job XY0 or modal versus absolute. Absolute XY0 is set by the limit switches. Now how do we know how to find those values? Well, on the screen up in the settings there's a pull down that says positions, and the positions have two different tabs. One says positions and they're prefaced by a P letter, and then there's home positions that are prefaced by H values. Now these values I had programmed in prior to this discussion. So let's take a look at this P4. It says black cone. Well, I don't really need that anymore, so I'm going to take black cone, highlight it, and delete it. And then I'm going to delete the X values, the Y values, the Z values, and the A values. So now that just disappeared. As you can see, it's no longer in the menu. Another place we can observe these positions, both the P positions and the H positions, are from this pull down menu in the upper right portion of the screen. You'll notice that the P's they come first, and if you scroll down past those 10 positions, then they jump into the H positions, or the home positions. So what are the actual differences between, let's look back up here again. What are the actual differences between positions and home positions? Well, you can see that there's a number of blank spaces, and all of these are up for grabs for the user. So in my case, I run a job on my table that has identical fixtures, one on this end of the table and the other on the far end of the table. And I want to load one fixture while the other is machining, and when it's done it should stay there until I tell it to come back up here. But I don't want to re-zero that job every single time I move this gantry. And so that's where these positions become real valuable. In order to fully grasp the value of these programmable positions, we need to understand a little bit about G code. So right now you'll notice that the DROs, the digital readouts, are all zeroed X, Y, and Z at that position. So if I retract the Z-axis, now if I tell this machine that I want to move 1 inch back that way and 1 inch in the positive X direction, I would type in G0 X1 Y1 and hit enter. And when I hit enter, watch what happens. Okay, so you can see that it actually moved over 1 inch in the Y direction and 1 inch in the X direction from its previous set point. So if I want to go back to this position exactly again, I can type in G0 X0 Y0 and hit enter. And there it is, right back where it should be. So we know that G0 commands will move the spindle position relative to where the XY values were set previously. Now there's another command called the G53 command. So let's use that G53 instead of G0. So I'm going to type in G53 X0 Y0 and hit enter, and let's see what happens. Well, that doesn't look anything like where the job was set up. In fact, let's look at the DRO. The X value, it's 12 inches to the left of where that was previous, where that cone is sitting, and it's 10 inches towards the front of the machine from where that cone was sitting. Now, take a guess at what that position is. It's an absolute 0, 0 position. It's where the machine ended up after homing. So if I take and pull down this settings and look at the positions, if I look at home positions, or let's just leave it at positions. I'm just going to pick one of these things like number 7, just for the heck of it. And you'll notice that the radio box here is checked absolute. If I tell it to get position, lo and behold, it puts in X0, Y0. But if I say I want the local position and get position, it's 12. It's the same as what you see on these DROs. So getting those positions is as easy as clicking this button right here. Alright, so let's program in a couple of arbitrary positions. We're going to do a P position and we're going to do a home position and see what we can learn about the differences. So here's a cone that I've marked P4 because I'm going to use the blank value number 4 to signify where this is. And I'm just going to drop it on the table, and then we're going to go ahead and program it in there. So the first order of business is to actually move the head over. So just to save time, I'm going to move this cone to correspond to the spindle in that location, wherever it is. So the X, Y, and Z values for that position are where I want them. Alright, so with the spindle positioned exactly where I want it, signifying that P4 cone, I'm going to go over here and bring up the settings pull down menu, go to positions, and here's the P4. I'm going to move the cursor down to there and say, it doesn't really matter, absolute or local, I'm going to get the position. And we're going to call this position name test P4 and say OK. Now if we look at this pull down menu, there's our test P4. So let's test this thing out and see what it does. Now take a look at the DROs. Even though it's at a P4 location, these DROs are still referencing that job XY0 because programming this position had nothing to do with this position. So those numbers, the minus 3.5 and minus 4.5, are actually offsets from where the job was set prior to this. Okay, so now I'm going to retract the Z-axis a little bit, and I'm going to tell it that I want to go to G0, X0, Y0, and hit enter. And you can see that it went to where the job was. Now let's go over and pull this menu down and go to test P4 and say go. Look at that. It went right over to where we had assigned that P4 value. But let's look at the DRO. The DRO doesn't say X0, Y0. It's got that goofy minus 3.5, minus 4.5. But that's, again, relative to where the XY0 was last set. So programming these values don't have anything to do with messing up where the XYZ value was set prior to it. Now let's just say that was our new job position and we wanted to set the XY values at 0 there. Well, that's as easy as clicking the XY0 button on the screen. It'll set X0, Y0. Now you'll notice that when we sent the spindle to the P4 position, that the Z value was also sent down to the where I had set it prior to this with that get position, because that's where the Z was sitting when I went and got that position. But let's say we didn't want that Z to come down. Well, how do you compensate for that? Well, let's retract that Z, and we're going to go back to G0, X0, Y0, enter. You can see the spindle is considerably off that cone. If we send it to the P4 position the way that we programmed it, that spindle would come down right to the tip of that cone. So let's modify that P4 a little bit. So let's go up to settings, positions. There's our test P4, and you'll notice it has a Z value in there. Let's just get rid of that. Delete it. We don't want to put 0 because that's a value. So we'll just delete it entirely and say OK. Now let's send it back to the P4 position again. So we're just going to take that P4 and say, see, that's focused, there we go. And we're going to say go, and let's watch what happens. It went directly to that XY P4 position, but nothing happened with the Z. So that should tell you a little bit about when you're programming these positions. If you leave something blank, it just ignores it. If you put a 0 in there, it's going to try and go to 0, and you got to be real careful with putting anything in that Z box, because if depending upon your offset from your tool height, you could crash into things. So until you really know what you're doing, I would say just any entry in this Z value, just get rid of it. Okay, so now let's say I programmed a job, and this is the center point of my job, and I want to go ahead and run the G code for those tool paths. Well, even though it's physically positioned here, you can see that the DROs still say some goofy numbers in the XY values. So let's hit the XY0 button, and we have now reset the XY values for the job. So now this job XY0 is no longer valid for running until we go back there and find that exact spot again and tell it that it's XY0. So because I hit that XY0 key, this is now the new center of our job. So I'm just going to take this off the table. Alright. Now let's say I want to program in one of these other values. So let's go positions, and we can see that there's home positions. Okay, so you'll notice here the H4 is blank. We're going to use that for this cone. And you'll notice that there are no radio buttons on this screen like there are on the position screen, which are absolute and local. So we'll go back here, and I can just tell you for a fact that they're all absolute. So now let's say I want to run one job there, and then over here I want to run the same job while I'm taking something out of that fixture. So what we have to do is go over and find that position, and I'll do that now. So what I did was I jogged the machine over to this H4 cone and set it right over the tip. Back on the screen, we can see that the DROs are still relative to the P4 cone because that's where the XY0 was before. I'm going to go to the H4 position and I'm going to call this test H4, and I'm going to hit the get position button. And like before, I'm going to get rid of the Z values because I don't want those in there. And I'm just going to get rid of the A too, so there's no ambiguity. And OK. Alright, so now this is going to explain very clearly what the difference between the H position and a P position is. So if I tell the machine to G0, X0, Y0, it will go over to where it was for the last job. Alright, now if you can see that it's at XY0. Okay, so now let's find that H4 and go and watch what happens. It goes over to that value just like it did with the P, except look at what happened to the DRO. It reset itself all by itself to X0, Y0. Alright, let's go back to the P4. Go. So now it went back to the P4, but guess what? It didn't reset the X, Y to 0. It just so happens that I moved it over exactly along the X-axis, so the Y value didn't change from one to the other. But had I done that, both of these would have switched. So why are the DROs like that now? It's because this is the new XY0, and this is the modal or relative XY coordinates compared to this one. So the moral of the story is, if you program a P position, the head will go there and it will leave the DRO relative to your last XY value. If you program a H position, it will go to that position and reset the XY values to 0. So now we've got these two home positions set. Right now it's sitting over home 4. And we can see that the DROs are 0, 0. If we go to home 5, go, you can see the machine is moving. Let's look at the DROs. As soon as it got there, it reset them to 0, 0. Let's go back to home 4. It's going back. Lo and behold, set the XY values to 0, 0. So where this is really useful is, let's say you have two different fixtures. You have one here and you have one over here. They want to run the same job. or different jobs as far as that goes. If you, but in my case, they're the same job. I send it to H4, run the G code, then I send it to H5, run the G code, send it back to H4, run the G code, and just keep doing that until the job is done. The Z values are remembered from when you last set the Z. So if you set the Z once and your Z values on your position settings are blank, it uses the ones that were set last. So that's a safe way to traverse the table without worrying about having your cutter run into anything. Assuming, of course, that it's high enough when you navigate your terrain there. So to recap, we can use the P values to send the machine to a certain location, and the DROs will read out relative to the last XY positions. If we send it to an H position, it will go to that new position and reset the DRO to XY0. Now it's also interesting to note that you can use both the H values and the P values on the command line preceded by, let's say, G0 command. So you could say G0 P4 for instance, and it will go the offset values, not absolute values, the distance that are in those dialog boxes. So even when you use the pull down menu to go to a P position, it will automatically precede it with a G53 command. You can manually say G0 P4 and it will move relative to the last XY value that was set. Now a lot of this is confusing until you actually play around with it a little bit and discover how useful it is for running everyday jobs. Thank you for watching, and I hope that you found something useful in this video that you can use in your shop on a day-to-day basis.